So I'm continuing through this discussion of specifications and specification-driven development here. We had covered quite a bit last time, and that built on earlier understanding on property-based testing and how it fits in with AI tools. And I'd refer you to some supporting tools like Kiro or like Quick Check or Quick Strom rather, or Antithesis, etc., and some libraries available. And I had talked about properties and looking for properties, and we had talked through a couple examples, including a queue where you had made some suggestions for properties associated with an interface there. And we could spend more time on it, but I figured in the interest of delivering value and equipping you as early as possible for building on some of this knowledge, that I would go on to talk about some additional types of properties that are guaranteed, beyond those that are algebraic, beyond those that involve, like, you perform this operation and then that one, and it has this property, or if I add E, I add F, and I peak, I get this, the head will be E, etc. These algebraic properties are important. I do anticipate that you may be able to find a fair bit of them, particularly once you think about get, set type of operations, etc. But I want to talk about today about some additional types of properties and rehearse some things related to those we've already covered. So we've talked about, oh my goodness. Well, this is okay. Never ceases to surprise. No. That's something else. Okay. So there's something about Logan being let into the room. Is that someone said?
Sorry, my Zoom was saying that the meeting had not yet started, and I messaged in the Discord and people said that the meeting had started, and I rejoined and let me in, so we're all good.
Oh, I see. Okay, well, good to know. Relieved to hear that's one less thing to worry about. Okay, so I'm just going to see if I can frob these video settings to have the right resolution. Yes, okay. Great. I think we'll have less of a problem now. But yeah. So I'd like to talk about some material we haven't yet read. So we talked about preconditions, post-conditions for methods. We've talked some about algebraic properties, right? So we talked a lot about last time. And all those are really important, but I want to introduce today not only some additional examples for those, but also a discussion of invariants. And I'm calling them abstract invariants because they have to do with kind of they're not properties of a particular implementation, they're properties of the behavior of the system, the structure involved, the typing, as it were, not of the particular implementation of it, not of how it happens to be realized in code. A given behavior might be realized with several different sequences of code that all have the same impact. I'm talking about properties of the interface or class or module as a whole that are abstract invariants in history properties. And I want to make sure you're well equipped to identify those in your projects. So we're going to have some examples, and I'm going to be asking you questions for some of these that try to build on some understanding that I tried to introduce in previous lectures. And then we'll go on to some of these additional ones for each of these examples in turn. Okay, so here's a interface to be captured in a class. So we have a counter, and you can read the specifications as well as I can. These are informal specifications. These are English language specifications. When you create an instance of the counter, it initializes the value of the counter to 0. Kind of keeps track of a value when it's first created at 0. You can at any time get the value of the counter, it's an integer. And alternatively, you can increment the value of the counter. And it will increment it, it will increase it by 1. So I placed here for the latter two methods, for get and increment, some statement of requires. We could have put true. I happen to put none as the more common, or in my experience, that's a very common way of denoting it. It may be, if I had to guess, more common than just putting true, but either would do. I'd certainly accept either of those. Ensures here the resulting value, the value being returned, is greater than or equal to 0. So it ensures that. Okay, getting increment, it requires nothing, but it ensures that the value that we get is what? Can anyone interpret this thing on the right? Yes, Tyler.
And it was valid before it's called +1.
Yeah, so if you took the value as it was before I called this, and I added 1 to it, I get the value that's returned. Following. So it ensures that whatever value it is, after it, if I call get on it, it's the value I would have gotten by calling get before +1. Are we good with that? Pretty clear? Okay. So those are preconditions and post conditions for some methods. Let's talk about algebraic properties. Well, you tell me what's in. Can you look for any algebraic properties here? What are some properties? You can also, yes, Tyler.
The property between get and increment
Good.
in the infer section, saying that this is what get will.
Okay. So yeah. So if you call get after increment, you should get the value that it was before +1. That's kind of that is stated in increment. You're absolutely right, but it is a property of this situation involving those two methods. Good. How about another property? Yes, Himanshu. Sorry. But they're all using counter. That's true, but that's so that is an observation. It's not a property that we're looking for. There's no relation involving this. You do this, you get the same thing as that, and that's really what we're looking for. So how about get? If you think about things that don't change. So if I call increment twice in a row, do I get the same value as if I called it once? Get? I was right. And if I call it twice, I get the same value as if I call it and I discard that value and I call it again, I get the same value that I would have gotten by calling it once. It doesn't change it, right? People clear about that? Certainly if I create the counter from the get-go and then call get on it, I also get 0, right? If I create it and then call get, I get 0. We good with this? Okay. So maybe I'll ask about, so getting down to abstract invariants. I want to hit in this up. So what we're looking for abstract invariants. are things that hold true, properties that hold true. Relations that hold true, this equals that, or this is greater than or equal to that, or what have you. For each and every single time, each and any time point you give me, this should hold true. That's why we call it invariant. It never fails to be the case. It's something we can count on invariably. It never fails to hold. What's a property that never fails to hold here? Yes, sine. Great, the result, yeah, so whatever counter is given to me, you give me a counter, I don't know where it's been, I don't know, was it just created or was it created by someone way off in the system who called increment many times on it, maybe it's called get a bunch of times, but if there's one thing I know, it's that its value is greater than or equal to 0. So if I call get on it, I will get a value greater than or equal to 0, right? It cannot be otherwise, right? It is of necessity in this interface. Do you get it? Like in this interface, there is no way you could produce a counter whose value is less than 0. I don't care what sequence of previous calls were invoked on this thing. I don't care how recently or how far ago, long time ago it was created. There's no way in which it could have a non-negative, it could have a negative value. Its value is always greater than or equal to 0. Could it be 0 itself? Yes, if it was what? Just instantiated. Maybe get has been called a few times on it, but increment has never been called. Could it be 100? Yeah. Could be any value 0 or more. Do you get that point? So here it's as an abstract invariant, it's greater than or equal to 0. You comfortable with that? Can we tighten that? Is there any way we could rule out certain numbers greater than or equal to 0? Not particularly, right? This thing could have had int called any or increment called any number of different times. Do you folks get that point? Okay. Now, the other thing, though, I want to talk about that's a new concept, and we're going to be going through each of these for successive examples, is history property. So I want to contrast these to abstract invariants. Abstract invariants are properties that hold at any one time, at any time you pick them. Each and every time this property holds. But we're focusing on, any specific time, any single time point. History properties are properties that obtain when comparing the system at two different time points, different times. It's something that is a property of how it changes over time. So I want you to tell me, what's some way in which this changes over time? Are there certain properties about how this changed that you can count on as a developer, that you might rely on as a developer? Tyler. Excellent. So if we consider it now or at a time t, and we call get, it'll have some value. And if we consider some later time, call it t prime, so later time. Same time could be later. The value then will always be, and you use the keyword greater than or equal to the value now, or the value at time t. And could it be equal to the value at time t? Yeah, so how could it be equal to if what?
They didn't call increment.
They didn't call increment between. Could it be greater than it? Yeah, if they called increment, right? Okay, so here we're comparing the value at different times. Now you may be wondering, like, yeah, so if we have a history property, what of it? Like, big deal. Who cares about a history property? Well, if you have a loop and you're using a counter, you may be using that counter, for example, the value of the counter to stick things into array positions, and you're counting and not overriding earlier ones. The fact that it doesn't decline in value means you don't have to worry about overriding earlier ones. That it can only go up. Would you be shocked if you had a counter like this? If someone said, hey, this is an instance of counter, could you be shocked if you took this value now, you got get on it, and then later on in your code you call this value again and the value is less than or equal to that? Yeah, it could introduce a bug into your code, like you're counting on this property. So what we're talking about here, folks, are properties are things we can count on. A programmer looking at this might reason about it and come to the reasonable conclusion that its value can't decline. And they could, in their code, count on that for their code to be correct. Like that example I gave, they're counting on it not declining to avoid overwriting earlier elements of an array they're writing to. Okay, so for a counter at time t1, a counter c1 at time t1, and that I should really say counter c1 at time, so I'll just call it c, counter c at this time, and then its value at time t2. Well, okay, fine. I'm saying what its value is at each of those times. I won't try to fix it here. The value at a later time is greater than or equal to the value at the earlier time. You got that point? It doesn't decline in value. It could be the same, or it could be rising. And this could be something someone looking at this interface could reasonably count on. Looking at it, a programmer could reasonably say, there's no way this could decline. And I'm going to count on that in my code in some way, in some for loop or some switch statement or some if or what have you. Okay. Now we're going to go to, so are people feeling comfortable about this? Are there any ones of these that you're not comfortable about? You comfortable in the preconditions, postconditions? Tyler? Yeah.
For spotting history properties, I guess we're going to keep looking for like the word old inside of like.
Not necessarily. That's a very good question, Tyler. Like, might that be a good thing to look at? Could it be good to look at? Yeah, but don't confine your attention to that. Okay. I mean, like, yes, that might clue you into some. And in fact, here it would, right? With the preconditions, postconditions, you have this old, and you see, oh, this one is bigger than that one, bigger than the old one. So that's a very good idea, Tyler. It's a very perceptive question. But it might not always be that obvious. And we will, what's that? That is a good question. I would need to think about that. It's an interesting question. Could there be a history property which you could not deduce by the presence of any old reference to old? Well, I will say this. If you're counting on that, you're counting on this being available, like preconditions, postconditions. And there may be some times where your team does not have a formal specification in place. So there's no reference to old Tyler, but you can reason about history properties still. You could come up with history properties, even though all you have is informal characterizations like that. So I wouldn't count on it. I wouldn't use that as a reliable guide because sometimes those sort of formal characterizations of preconditions, post-conditions might not be available, like this. Okay, and in fact, for several of these, I won't have it. Okay, but really good question, very thought-provoking. Okay, so now we have a resettable counter. This is like our counter before, except it has a bell and we've added bells and whistles to it, particularly in the form of reset. So at any time, we can reset the counter to 0. Okay, so first of all, how does that change preconditions and postconditions? Yes.
I would say that we probably have.
Well, the history property doesn't hold true. Good. This is a perceptive comment. That's right. Certainly it doesn't hold true as stated. We'll come back to that point, as previously stated. How about preconditions, postconditions? Anything differ for the precondition, postcondition for the constructor, for get, or for increment? They're pretty much the same. Reset. Well, postcondition is that get after call reset, get is equal to 0. Algebraic properties. Are there any sort of different things in the combinations of these methods? If you do this and then you do that, you get the same thing as doing this and that, or you get some particular value. Anything? Yes, Theo.
You're implementing and then reset. It gets really different when we started.
Good. So if you
Assuming you incremented before, it wasn't too much. So
okay.
Increment, get, then increment, reset, get.
Okay. So
That's a lot.
that is true. So increment, reset is going to give you the same thing as just reset, right? It has the same effect. But let's ride that horse further. Let's think about some additional ones. I like how you're thinking about you do this and then that, and you get something. Yes, Talha?
Maybe that reset can be called multiple times and still get 1 for 0.
Good. Calling reset once is calling reset any number of times beyond 1 is the same as calling it once, right? There's no use calling reset more than once in a row, right? Once is enough. Good. Others? Yes, Himanshu.
Initialize get will give same as reset get.
Initialize get will give a very particular value, which is 0. And that's the same as reset get. That is true. That's absolutely true. Good. There was one before we had related to get. It related to what get doesn't do. Yes, Martin.
That isn't guaranteed to always be greater than or equal to anymore. You call get and then you increment it and then you reset it to be less than.
That's true. That is true. I'm more thinking as an algebraic property, so we'll come to that. But if you call get once and then you call it twice, you get the same value as if you called it once, right? Doesn't change anything, right? Good. So this reset has added to the texture. Let's talk about abstract invariants. Do you remember the invariant that was in place for the previous one when we didn't have reset? Remember what that invariant was? The thing that was true at any single point, any period. point in time you give me, I can tell you what the invariant, what property holds, yes, the
Greater than or equal to zero.
greater than or equal to 0. Is that still true?
Yes.
It is. Is the history property true? No. Not as previously stated. Okay. So abstract invariance is still the case. History property. If there are two periods and there's no implication of reset between them, it will rise, or at least it won't decline. But in general, for any 2 points of time, where you don't know what the sequence was before, maybe you like created this counter and you passed it somewhere off in the code, you don't know what they've done with it. And after you call that thing, you're using it again, you don't know if its value now is greater than or equal to when you passed it off, right? They may have called reset. So the history property, in general, you don't control like when they're going to call, reset if you've passed it somewhere else off. And so it's only there's only that history property obtaining if you're sure they haven't called reset. Are we comfortable with that? Okay. Okay. Dual counter. So here we have dual counter. You have 2 counters, not just 1, 2, I tell you. 2 counters at our disposal. Move it up in the world. Do a master's degree, you get a 3rd. Nice. Dual counter. Okay. So the constructor initializes both to 0. You have get and you have get 2. I've said, like, you get the first or you get the value of the second. You could increment the first and increment the second. By 1. Increment will just increment the value of the first counter, increment 2 will increment the value of the second counter. But in both cases, they're incrementing it by 1. Okay, so what are some preconditions and postconditions for this? Yes.
It's
Theo?
basically the same, except it's
Yeah.
referring to its specific increment.
Yeah, that's right. That's right. So very similar preconditions, postconditions from before, right? You have pretty simple adaptation of what it was before, but it refers to the specific counter involved, right? Good. So increment yields the value of counter 1 to be 1 bigger than the old value of counter 1, and increment 2 changes the after increment 2. If you call get 2, the value is 1 more than it was with the old value from this counter for counter 2 specifically. Okay, how about algebraic properties? Okay, I love seeing enthusiasm from a core group, but I'd like to get more people too. Was that a hand tall, huh? Or no? Okay, Himanshu. Yes. You can't. I mean, you call GAD and it returns the value of counter 1. You can't tell it do it on counter 2. If you want to get the value of counter 2, you call get 2. Yeah. Yes, Tyler.
Question, like, what is the key thing that separates abstract invariance from algebraic properties?
Good question. Algebraic properties are going to characterize. It's almost, I think it's a fair thing to say, you do these things and it's equal to doing those things. And so, for example, you call reverse on a string, it's the same thing as doing nothing on that string. The string itself, right? You take you say S is a subset of T and T is a subset of U, and it implies that S is a subset of U. These involve equivalences, like saying you do these things, it's equal to doing those. An abstract invariant is not actually stating here that there's some equivalence between properties. Like, let's go back to the very first one. So here I'm not saying do this, then do that, and get equal to to this sequence of doing things. I am saying something that there's a property involving it. I am saying that there's a value involved. But in general, so I guess your question is, could this be seen as an algebraic property? The key thing here is that we're saying at any point this is true. And you could say, well, yeah, okay, if at any point I invoke this sequence, I get back a certain value, and here the value I get back is just greater than, that it equals 0. So if I do reset and I do get, I get equal to 0. So that's an algebraic property? Why is this not an algebraic property? Maybe that's a reasonable thing to say, that this is a special, it's kind of a very special type of algebraic property that we want to say this holds each and every point in time in a way that we can count on regardless of the values that counter C. Could you say, yeah, this is an algebraic property? Maybe. I won't dispute that. I prefer to think of this as something that holds at any one time. It's like something I can count on being the case as a property of this thing, rather than a result of an interaction between different particular methods. The algebraic properties are dealing with interactions between these methods. Like, you call those twice, you get back something that's the same as calling it once. You call increment and then get, and you get back something that's one more than if you called, just get before. Like, those quintessentially involve like different sequences of calling things. Whereas this may be a simpler property as it is here. We're not seeing how they play together nicely in terms of interaction and providing certain guarantees. Could you say this is kind of a degenerate, a kind of very, very simple algebraic property? Yeah, I think, I'd say that's probably a fair thing to say. But its focus is different. Its focus is not how do things play together nicely to guarantee certain properties. It's rather, what can I count on it being the case at any one time about the state of this object? This is stating something you can count on. For any counter, I can count on this being the case. And it often is something that is true at that point without performing more. I think this may be part of it. You're not performing more operations typically. It'd be kind of weird for an abstract invariant to say, well, if I do get and then I do increment, its value is greater than or equal to 1. No, I'm really looking for something that's true without changing it. And this is kind of a testimonial to that. Okay. Great question, though. Other questions? So this stuff is going to end up being the focus next week for Liskov substitution principle. So these same issues are going to come up with Liskov substitution principle. Okay, let's talk about abstract algebraic properties here, though. What are some algebraic properties of this structure? Himanshu, yes. Sorry, get twice will give the same value as getting it once. Is that what you're saying? Yeah. How about get 2? Same Same thing, mutatis mutandis. Doing get to twice in a row gives you the same value as doing what? Get to once, right? That's why I say mutatis mutandis. You have to change the inessential. Okay, so that's true. What else does get not change? It doesn't change the other complex value too, right? So if I do get twice, I get this same value as doing it once. But not only that, get two hasn't changed its value as a result, right? And the same thing true mutatis mutandis for get two. Tyler, did you have your hand up?
It's the same thing,
Yeah.
that's,
Mm-hmm.
printing one will not affect get two.
Good. Incrementing one will change the value of that one, right? So increment will change the value of that counter such that it is one more than it was before you called increment, yeah? But it will leave unchanged increment two. And conversely with increment two in mutatis mutandis, right? Good. Any other things come to mind? How about right after you create it? You create it and then do get, what do you get? Zero. You do get two, what do you get? Zero. Yeah. Okay, so there's some simple properties here. There are certain things that play together nicely. Increment and then get gives a very specific value compared to just get by itself. This is why I say algebraic properties have to do, if you do this and this, it's the same thing as doing that and that. You know, you do increment and get, it's the same thing as doing get plus one, old get plus one. And these have interesting things of what they don't touch, what they don't change, right? History properties, or sorry, abstract invariants. What thing is true? What things are true at each and every point? What aspects of this state are true at each and every point? Yes, Theo.
Same as before, just. It'll be greater than 0.
Be greater than or equal to 0 for each. Yeah. And they never can decline, right? Okay. Good. Good. History properties. Terrible. My apologies. I'm gonna spew out a name that I think is wrong, but for some reason it's hashed to that bin, and maybe it's correct. Ben?
No.
Okay. Big Ben. No. Okay, so put me out of my misery. Matt Berry.
Yeah.
It's the B that, yeah. Okay, somehow the B infected my first name. Okay, basis. Yes, Matt. Okay.
For history, the value of each counter can't decrease over time.
That's right.
You
That's
can't
right.
compare between the two counters.
You cannot compare between the two counters. That's right. That's exactly right. So if you compare it, so if we compare time point 1 and we do get and get 2, whatever values we get for those, call them S and T, right? Let's see, actually. Okay, so if we do get and we do T equals, okay, now I'm really screwing this up because I shouldn't call it T because I said time T. So it's just inviting confusion. Okay, call it R. R equals get 2. So this is at time 1. And then before I called it time T and time T prime, so I'll stick to that. If I get here, you're saying at this time, Matt, the value of get is what? How does it compare to S?
Greater or equal.
Greater than or equal to S. And get two is
Greater than or equal.
greater or equal to R. Right? But there's no bearing on, get compared to R, get two compared to S. We good with that? People comfortable with that? Is there any other, history property that we should be able to state? That's pretty much all we can count on about the relationship between them. Yes, Talha.
Street property, but I have a question. So
Yes, good.
if we knew the preconditions and post conditions for both increment functions,
Yes,
and we knew that they were incrementing by the same amount,
yes.
because it's not necessarily specified here.
Correct. Yes. You were absolutely right in saying that's why I said verbally they increment it by one. But this is actually this is not a well-written specification.
So then would it be a good algebraic property to have like dual counter dot increment equals dual
Yes.
counter dot increment two? Is that agreeable?
Yes. So if you don't have better precondition, postcondition, that would, yeah. Dual. So if you have a dual counter D, and you call increment, and you get its value now, and then you call increment on it, its value will now be one more than what it was before calling that increment, right? So in other words, let's put it over here for this side of the room, right? If I have a dual counter D and I call get on it, and I get some value B, right? And then I call increment on this. And then I call get on it. Its value how will it relate to V? Yeah, V plus one, right? And the same thing with if I put get two and increment two, so replace both gets by increment by get two and increment by increment two, right? Are people comfortable with that? Okay. So that would be a very good thing to say if you don't have a very precise specification. Yeah. Yeah. The word increment is pretty it is pretty loose, unfortunately. For most programmers, if you say I increment that, they probably are thinking about increasing it by one, but that's in Canada and North America. You can't be absolutely sure it carries over across languages, etc. Probably it does, but it's good to have something tighter than that, and certainly for like proving any properties in the future. Yeah, certainly the case. Okay. Speaking of that, let's do a thought experiment. I didn't pull this example, but let's suppose instead of being increment, we have increment by n, where n is an integer. Any integer, no restriction. How would that affect? It affect the precondition and postcondition for increment and increment two, because now they're going to take a. Let me just make it clear, because what I'm saying is I don't want you to hold it in your head. Let's suppose I did this, and I'm going to increment counter one by n by some integer n. And yeah, I know what you folks are thinking. Yeah. No, there's no statement that it has to be greater than or equal to 0. So, yes, Tyler.
I would say because it's just generic int, now we cannot guarantee that get will be greater than or equal to 0 since we pass negative numbers.
Correct. So, which of these things does it change? You could say, which of the things that used to be the case can we no longer count on?
forget the list of mentioned, but the greater than equal to 0 thing cannot be counted on anymore.
That's right.
That in the future, that it's always greater than it is now will no longer be counted on.
That's right. Exactly. The history property can no longer be counted on, because now it could go down, right? Because negative. The invariant, that it's always greater than or equal to 0 at any one time, can that be counted on? No. And certainly we can't count on calling get increment by some arbitrary number. In call get again, is that more than that plus 1? By contrast, if we said, well, this is in, some n, this would be v plus what? N, yeah, exactly. Okay, so break, like, suddenly we can no longer provide the guarantees that we had before, that a programmer might count on about the value of get or correspondingly, respectively, get to always being greater than or equal to 0, right? Same thing for history properties, we can't count on either counter being greater than or equal to 0, right? Good. Does it change any preconditions except that for increment and increment 2? No, it's the same, preconditions. Okay. Okay, now the plot thickens. Okay, we have fun. Okay, so we have our dual counter, and now we have a swap operation. This swaps the two counters. Okay, post conditions, the preconditions, post conditions. Does it change the preconditions, post conditions for get? For get 2? For increment? For increment 2? No. What is the precondition and postcondition for swap? So preconditions. Anything it needs to do its job that if you don't provide, it can't do its job? Yes, I'm.
Get and get to instead of a value greater than 0.
It initializes both to 0 when this is initialized. Is there any way they could have a value? They could not have a value? Well, a constructor is going to be called. So a constructor is going to be called, it's going to initialize to 0. Once it's initialized to 0, is there any way, both counters to 0, is there any way that they could become undefined? I'm going to put aside like rollover effects when you get beyond the end of the integers. Let's put that aside. Is there any way they could become undefined? We start at 0. We do gets on them. We do get 2s on them. If we do increments, we do increment 2s. Even if we do swap, would it make them undefined? No. So we actually don't have a constraint on swap 2 to do its job. Whatever the values are of those counters, it can swap them. So preconditions here are none. How about post conditions? Yes. So Sime, yeah.
Get is equal to get 2.
Okay, so the value after swap of get is going to be the value before we called swap of get 2, and vice versa. Value of get 2 after swap is going to be the same value as if we called get before swap, right? Thinking like old. When I say before, I mean like old get 2. Right? Okay. Okay, I don't have it written down here. Okay. Algebraic properties. Yes, Ananchu.
Swap 2 times when.
Good. Swap, and then swap gets you back to as if you had done nothing, right? Good. another algebraic property. We have those that we had before, right? If you do get and get, it's the same thing as doing get. If you do get to, and it doesn't change, it leaves get to unchanged also. If you call get to, it doesn't change that. If you call increment, the new value is one more than before you called it, but it leaves unchanged the other counter, right? Those things still hold. But now we've got this swap critter. And how does that behave? Yes, name. Jake. Thank you, Jake.
Initialize and swap.
Good. I like that. Good man. Yeah. That's pretty cool. That's pretty cool. My hat's off to you. Good. Another one involving other properties involving swap. Himanshu had his hand up. Yeah. Good. Yeah. So get, if we call get, whatever we get back is equal to if we swapped in get to, but so that's true. Yep. That is true. And mutatis mutandis, right? If we call get to, we get back the same thing as if we swapped and call get, right? Good. Are there others? Yes, Tyler.
If you call increment swap, get to will be the same as doing increment to get to.
Doesn't it just make you want to cry with its beauty? Okay, it seems I'm the only one weeping. I'll weep for all of you. Okay. Okay. So that is true. If you call increment and swap, it's the same as calling swap and increment to as well, right? And mutatis mutandis for the other one, right? If you call increment to and then swap, it's the same as calling swap and then increment, right? This is true. Yeah. If you call increment and increment to and then swap, is that the same as swapping and then calling increment and increment to? Yeah. It is. It's just beautiful. It's just beautiful. Okay. So there's a set of algebraic properties that are quite rich here. Do I think we've exhausted all of them? I suspect not, actually. I suspect that we may have missed one or two in here as well. Enough room for the final exam. Abstract invariant. I wasn't entirely about it. This is like no question. Whether I'm going to put this totally different question. There are lots of you. And then I get to cry while marking that. Cry for beauty if you've answered it correctly. Cry for tragedy if you haven't. Okay, invariants. Properties that are true at any one time. That like something that's true for one of these at any one time. And typically per Tyler's sharpening question, these would be things that are true at that time without changing it. typically we just expect them to be true. We generally don't think about, since we're focused on that time, not like the next time after we change something. Generally, these are things that are true about it, like right now. Is there any big difference from before with swap? Yeah.
So there's no big difference, just typical get and get will be greater than or equal to 0.
That's right. They'll give values greater than or equal to 0. Good. Good. History properties. I would like to have, so there's been a wonderful profusion of answers from here. I mean, it's just been a march of power through this section of the road. It's great. I would like to get someone else in the room. There's been an odd geographic, spatial localization of the answer. And I would like to put forward the need for team 2 to demonstrate its metal. METTLE. I'm not talking. Yeah.
Could I try this one?
Sorry.
Could I try this one?
Yes.
That's
another spatial component altogether. Yes. Speak on. Is this young Logan or is this
Derek?
Oh, it's Derek. Okay.
Derek. Sorry.
Yes. No, there's no.
So if you like at time, if you have time 1 and then time 2 is later.
Yes.
If you do a get at time 2, you know it has to be greater than or equal to the minimum of the 2 counters at time 1. Because they could have been swapped, but they couldn't. Neither of them can go down individually.
Okay, my hat is off second twice now. That's right. Exactly. Yes. So why can't we just say, well, the value of get at a later time is greater than or equal to the value of get at an earlier time? Why can't we say that?
Because it can be swapped.
Because it can be swapped. But what Derek has done is he's cleverly arranged the property to account for the fact you can swap, right? And specifically by mentioning this notion of the minimum, because it's not going to be able to go down by swapping to a value that's less than the minimum of the 2, right? So he has built that property with this kind of fail-safe in it, as it were, that will hold even if you swap it any number of times. So suppose they swapped it 0 times. Would Derek's property hold? Yes. It might not be as strong a property as if you knew that there was no swapping going on. You could have sharpened it by saying its value now is greater than or equal to its value then. But at least it's true. It holds true. If they've swapped it once, does it hold true? Yeah. Let's suppose it swapped it twice in a. If it's twice in a row, Himanshu, state it again. If it's twice in a row, then it's the same as what? Not swap, you get all, right? So that holds true. If they swapped at different times, you swap, maybe you swap and then you increment, incrementing various ones of the counters, and then you swap again, and just kind of on an ongoing basis. Does that invalidate Derek's comment? No, it doesn't, right? It's still greater than or equal to what it was at the whole start of the sequence, the minimum, greater than or equal to the minimum of the 2. People comfortable with that? That's a history property here. So to be very clear, and I just want everyone to follow along with this, if we didn't have swap, you consider the history property absent swap. And then we consider the history property with swap. Are they different? Yes. Swap changes our history properties. It prevents us from making as strong guarantees about history here. Are we comfortable with that notion? Is that pretty clear? Okay. What if we threw reset into the mix here?
In terms of just history, or
Sorry?
it's in terms of just history, or
Well, certainly it would require its preconditions and post-conditions. Would it change any of the preconditions and post-conditions of these others? No, they're preconditions and post-conditions are very localized things. They're not about emergent properties that come from calling different things. No. They're very localized things about if my preconditions hold, then my post-conditions hold. Really, adding reset wouldn't change the precondition and post-condition. It would require its own, right? Algebraic properties, would it invalidate some of the algebraic properties from earlier? Like, would it, yes, Simon?
The properties that initially would fall to 0, and without reset to 0.
Okay, yeah, so you're saying there are new properties involving, like, if I do reset and swap, it's the same as doing it's the same as doing swap, and then if I do reset and swap, it's the same as swap and
Reset.
right? Oh, the tears just flow. So that's an algebraic property. Does it invalidate ones we were talking about earlier, like swap is the same as doing nothing? Same as identity? No. Doesn't change that. Or saying increment and then swap is the same as what? So I can increment 2, right? Does it change that? No, because those are about interactions of specific methods that were there before. It didn't break those methods. In this case, there's nothing that, that reset is going to do if it's not part of that sequence. Does it have more properties associated with it? Yes, it does. And this is what Simon was getting at. Reset and swap is the same as swap and reset. So is reset and then increment the same as increment and reset? No, it's definitely not. Is there a property involving algebraic property involving, like, resetting and getting gives you something? Resetting and getting gives you what? 0. Resetting and getting 2 gives you what? 0. If I do increment and then reset, that's just the same as doing what?
Just reset.
Just reset. If I do increment 2 and reset, it's the same as doing just reset. There's no point in doing increments before reset if there's no gets in the way, if there's no one to observe them along the way. We can do all the increments we want, but it's full and sound of fury, and it signifies nothing, in the immortal words of the bard, right? Right? It signifies nothing because they'd be wiped out by the reset. Hey, that can save us. That's like optimization territory. That can save us. We don't have to do these increments before that, right? If there's no gets along the way, no get twos along the way, no swaps along the way, right? Starting to get a bit of a flavor of those algebraic properties. Okay, how about abstract invariants? If we have reset here, does it change our abstract invariance? Like saying at any one time it's greater than or equal to 0? No, it's still true, right? Still true that it's greater than or equal to 0. Does it change the history properties? Yeah, big time, right? You can't necessarily guarantee that it's going to be bigger at a later time than what does earlier. We good? Okay. Well, you folks were, those online were spared my mean, and that's MIEN. And I wish you rapid recovery, and I look forward to reviewing your